Hi, my name is Tony Ingesson. I'm an assistant professor of political science here at the Department of Political Science at Lund University. In this two-part video lecture, we're going to talk about visualization. More specifically, we're going to talk about how to visualize data as well as abstract figures, illustrations, models, whatever. We're going to talk about good examples, bad examples, and some principles that you can use to develop and create your own visualizations. And for this lecture, I'm going to mainly use two books by Edward Tufte. The first one is called The Visual Display of Quantitative Information. And this mostly concerns statistical data and numerical data. The second one is called Envisioning Information and deals more with abstract figures and illustrations and such. So if you're interested in this kind of subject matter, I strongly recommend that you take a closer look at these books because they are quite good and useful for this kind of endeavor. But before we proceed, we first have to establish what is visualization. Visualization can be divided into different categories. The first one is data graphics, the visual display of measured quantities, presented as statistics, for example, in charts, etc. The second category is design strategies for enhancing the dimensionality and density of portrayals of information. And this is where you would put more abstract kinds of data, such as maps, illustrations, timetables, etc. In this lecture, I will cover both of these categories. Illustrations are used often, but rarely with any great degree of afterthought. Remember that a poor illustration is actually worse than no illustration because it can be misleading and confusing. Illustrations can be used to highlight things that are difficult to see, but also to conceal that which someone wants to hide or distort. However, through basic knowledge of graphical principles, we can learn how to see through graphical deception, as well as avoid unintentionally misleading or confusing representations ourselves. Consider, for example, the infamous coffee chart meme that has been circulating on social media in the past months. What do you think is the problem with this chart? Consider it. I'll give you the answer, as eloquently presented by Twitterati Steve McCormick, a mathematician. What you see in the coffee chart meme is actually only 11 choices. You don't have as many choices as it represents it to be. You only have 11 variations. The rest are just the same variations used over and over again. So by reducing it to these 11 variations, as Steve has done, you get not only a more efficient chart, you also get a more correct one. Now that we've established what visualization is, we're next going to look at some patterns and how to highlight patterns using visual techniques. Here's another example, one from Tufte's Visual Display of Quantitative Data. This map projects data regarding all types of cancer among white females, age-adjusted rate by county, 1950 to 1969. As you can immediately see, this shows a very interesting variation. Some counties have much higher rates of cancer, as represented by darker colors than other counties. So this could, for example, be used to inform public health decisions, medical procedures such as increased screenings, etc. So this could be very useful from a public health perspective, and it is cognitively very easy to process. You immediately see what the important variation is. Note the high death rate in the Northeast and around the Great Lakes. Here's a similar chart, or similar map And this shows all types of cancer for white males, age-adjusted rate by county. The previous one was white females. This one is white males. Again, 1950 to 1969. The pattern from the previous chart is to some extent repeated, but there's also a key difference here. Do you know what it is? Before we proceed, again, note the high death rate in the Northeast, but also in the South and around the Great Lakes. If we put these two maps side by side, you can hopefully see quite easily and quite quickly what the key difference is. Men in southern areas have higher rates of cancer, and as it turns out, this was due to occupational hazards, more specifically asbestos used in shipyards. Now compare this with trying to spot this difference in data tables where you have just the numbers. So what we can see here is that projecting this kind of data onto a map, a detailed map, can give you very important clues on very important causal relationships. So consider this table. Here you have just the numbers. You have some very interesting things going on here, and also very interesting differences between these tables. But even if you're used to reading this kind of data, it still demands a lot more in terms of cognitive processing than simply doing this. Here you can immediately tell the difference between these four tables by using plots. Very simple plots. And this shows you the power of visualization, I think. Here's another example of what we call spatial data organization, which is when you use a map or some kind of physical representation of space to project your data. Some of you may recognize this chart. It is quite famous. Note these dots as well as the X's. The dots show deaths from cholera. The X's shows pumps, water pumps. If you look closely, I think you will notice that there is a pattern around Broad Street in the middle of the picture and the cross there. What this chart shows, or this map shows, is Dr. John Snow's cholera plot from 1854. And by using this method, Dr. John Snow revealed that there was a contaminated water pump that was responsible for this cholera outbreak. Dr. John Snow recommended the removal of the pump handle on this pump, which ended the epidemic. Again, you can see the value of projecting your data in this way. Here's an example of temporal data organization, which is when you project your data across time instead of across space. This chart shows monthly outgoing mail workload in millions of units, October 1968, October 1970, October 1972. And it is immediately obvious that something is going on here, because you have these very high spikes followed by very significant drops in monthly outgoing mail workload. And then the pattern repeats itself by going back to a medium level and then staying at a medium level, and then you have another spike. And you have this pattern repeating 3 times. What this shows is members of US Congress using taxpayer-funded mail to support their re-election campaigns, which they were not supposed to do. But this chart, again, helps you to cognitively process this information and see this pattern almost immediately. As you've probably already seen in news media and social media, visual techniques can also be used to deceive the reader and distort the facts. We're going to have a look at a few examples of how this can look in real life. And then we're going to look at what Tufte calls the lie factor, which is a way to measure just how exaggerated or distorted the data is in a given visual model. Look at these charts, and specifically look at the one I've highlighted with an arrow. It says 11,014 within parentheses. The next one says 397,747. The third one says 521,943. And these are all dollars. So what do you think is going on here in this chart? Well, since the first bar shows 11,014, that means that the zero should actually be just below that. However, they have chosen here to make these bars a lot higher than you would expect if you assume that they start from zero. Instead, they start from a very significant negative number. Why is this, do you think? What's going on here is that they're trying to hide a bad year by making these bars a lot higher than they should be and distorting the scale. So in this way, the first year looks like it wasn't all that bad compared to the other years, 1970 that is, but it was actually a disastrous result, efficiently hidden by using this very misleading kind of representation. Here's another example. What do you think is wrong with this one? Look closely. Look specifically at the bars that have diagonal stripes on them. As you can see, if you read closely, it says first half of 78, whereas the two previous bars say 76 and 77. What's going on here is that they are comparing full years, i.e. 1976 and 1977, to 6 months in 1978. So this gives the misleading image that there is a significant drop in commission payments to travel agents. However, you cannot really draw that conclusion without comparing to a full year. Again, this is misleading and it is probably deliberate. Another example of distortion. These illustrations are supposed to help you compare annual cost per capita for care of insane in Pittsburgh city homes and Pennsylvania state hospitals. So you have $147, $172, $198, and $213, and then finally $214. And these show different units: South Mountain, Pittsburgh, Harrisburg, Norristown, Warren. And what's the problem here then? Well, look specifically at the second last and the last examples, Norristown and Warren. As you can see, one of them has $213, the other has $214. Here they have exaggerated the difference through visual representations. So they use two dimensions, two-dimensional illustrations of these houses to give you an incorrect idea of scale as opposed to difference. And this is a very classic technique because for the eye, it's easy to tell that one is bigger than the other, but it's also difficult to tell just how much bigger it is. So you can use this to distort facts by exaggerating the difference in two-dimensional space. Here's another example of the same thing. The last line, representing 18 miles per gallon in 1978, is 0.6 inches long, whereas the line closest to the bottom is representing 27.5 miles per gallon in 1985, and it is 5.3 inches long. And this is supposed to show you fuel economy standards for cars. And probably the idea here is to exaggerate the difference, because the difference between these two highlighted lines is 53% in actual numbers. But in the visual representation, the difference is 783%. So as you can see, this is a very efficient way of exaggerating the difference, probably to promote a specific political line. And this also shows you how you can exaggerate difference through visual representation, but this time in 3 dimensions, as opposed to previously where you just had 2 dimensions. And this is what Tufte calls the lie factor. The difference between what the data shows and what the distorted graphic shows. So 783, which was the exaggerated representation in the previous example, as opposed to 53%, which was the actual difference, gives us a result of 14.8, which Tufte classifies as the lie factor. So the lie factor here is 14.8. The degree of exaggeration is 14.8. And this is a good way to analyze and measure the degree to which an exaggeration has been used. So remember, always be true to your data. Don't exaggerate in your visualizations. This concludes the first part of this video lecture. In the next part, we're going to look at good examples and principles you can use to design your own visual models.